In this video we're going to talk about simple equations. Now we'll define simple equations by example as we work our way through this. I'm just going to give some examples and show how to solve the various examples and what to watch out for when we're dealing with simple equations. So it's very straightforward. To most of you, you've probably done this in the past when you're at school or somewhere else, and this is just bringing it back into focus, back into memory. If you can remember it and you're happy with solving simultaneous equations and simple equations, in fact, if you can solve simple, simultaneous and quadratic, you don't need to watch these videos. You could do something else. But this is designed just to refresh everything, bring it back. So we'll talk here about simple equations. Now let's start with an example. If x equals 36 minus x, then what's the value of x? But the question seems a bit strange to start with. If x equals 36 minus x, what is x? Now the principle we have to work with on equations is whatever you do to one side of an equation, you must do exactly the same to the other side. Otherwise it will not be balanced. Otherwise it will be an inequality. So in order to maintain the balance, to make it an equation, we must always do to one side as we did to the other side. That will keep the balance. So try to see it here as like I've drawn it here, as a balance, and we've got a fulcrum in the middle. I'll just put the cursor on the screen there. We've got a balance in the middle. We've got on the right hand side we've got 36 minus x, and on the left hand side we've got x, and it's balanced. So that's an equation that's equal. Now we need to keep that balance, so whatever we do to one side here, we must do the same to the other side, otherwise it will tip up. So we can start here by adding x to the right hand side. So we've got 36 minus x. Well, if we add x here, we're going to get 36 minus x plus x, but of course we must add x to the other side. We've added it here, so we must add it over here, otherwise it's not a balance. So now we've got x plus x equals 36 minus x plus x. Now we can see here that the x's cancel. Minus x plus x, well, it just drops out. That's a 0. Minus x plus x, nothing. That leaves us with x plus x equals 36. In other words, we've got 2x is equal to 36. X plus x is 2x. So 2x equals 36. Now if you divide the left hand side by 2, we'll just get x on its own. But you must divide the right hand side by 2 as well. Otherwise it will not be an equation. Whatever you do to one side, do the same to the other side. So we've got 2x equals 36. Divide by 2. And if you divide by 2, 2x divided by 2 is just x. And on the right hand side we've got 36 divided by 2, which is 18. So the answer is 18. If you go back to the original problem up here, if x equals 36 minus x, what is x? Well, the answer is x is 18. So that will solve it. And if you substitute x in there, you'll find it works. So it'll be 18 equals 36 minus 18, which is true. Look at this and just say, is it true for all values of x? If we have a balance, we have an equation here, and we have x on one side and x on the other side. If we put in different values of x, will it always balance? Well, I'm going to ignore possibilities and debates that happen way down further in mathematics. We're just going to look at here as a simple equation, and that's what we're going to deal with it as. So if I add 1 to the left hand side, that's not balanced, it's tipped up, or tipped down in this case. X plus 1 is down and the x has been pushed into the air, so it's not balanced. So x plus 1 is not right. 2x, well, if I double the x, I have to double it on each side, that would balance. So x is balanced with x, therefore 2x will balance with 2x. X plus 3 and x plus 3, they'll balance. Whatever you do to one side, you've done the same to the other side. So x plus 3 will balance with x plus 3. They're the same. So we have a balance. We have an equation. If I take 1 away from x, and I don't take it away from the right-hand side, if I take it away from the left-hand side, x minus 1, the x on the other side will be heavier, to use the analogy. So the x on the right hand side will go down and the x minus 1 will go up. It's not an equation. So x minus 1, and I'll just put the cursor on the screen for a moment. This sign here, x minus 1 is less than, that's what that sign means, less than x. So when you see a little chevron like that pointing in that direction, that means x minus 1 is less than x. We use these symbols all the time. It's worth noting what they are. Now, some worked examples. Well, if 4x equals 20 minus x, what's the value of x? So that's a simple equation. There's no complications here with squares or cubes or anything of that nature. It's just 4x equals 20 minus x. Just write it down again to get into the center of the slide. 4x equals 20 minus x. So we'll start here by getting rid of the x over here. There's an x on its own over here. So you get rid of that by 20 minus x, writing it out again, plus x. But if you add x on the right hand side over here, you must add x on the left hand side. Keep it as an equation. So now we've got 4x plus x equals 20 minus x plus x. So we started off by just getting rid of this one here, this minus x, by adding x. But of course that meant we have to write x on the left hand side as well. So that simplifies because we've got minus x plus x, well, that cancels. We've got 4x plus x, which is 5x. 4 plus 1, 5. So we've got 5x equals 20. And if you divide 5x by 5, you'll get x. But that means you have to divide 20 by 5, which means you get 4. So the answer is x equals 4. Quite straightforward. Let's look at this example here. If 3x plus 2 equals 18 minus x, now we need to know what's the value of x. So 3x plus 2 equals 18 minus x. What's the value of x? Well, I've just written it out into the center of the slide, so that's just reproduced here, just to make it neat. Now, I start by adding x here. You see what I'm doing? I'm sort of skipping a move here, just because it's straightforward. We add x here, we add it over here. Add x here, we get 18 on its own. Add x over here, we get 4x. You can get rid of the 2 here. Take 2 away from here, you must take 2 away from here. So we have 18, add x to 3x is 4x, plus 2, take it to the other side, it becomes minus 2. So 18 minus 2. So we've done a couple of steps there, just all in once, because the arithmetic is so straightforward. And that means we've got 4x equals 16. So if you divide the left hand side by 4, you'll get x on its own. Divide the right hand side by 4, and you'll get the answer, which is 4. So that's quite straightforward as well, I think. Just making it a little bit more sophisticated. This problem is 3x plus 2 equals 6 minus a half x. What's the value of x? Many people may be put off by the fact you've got minus a half x. How do we deal with that? Well, it's quite straightforward as well. So we'll just write it up here. I've just written it up here. Normally I write it into the center of the slide to make it neat, but just put it up here because I need a little bit more space. So we've got 3x plus 2. If I take the half x here, add half an x, I'd get rid of that and I'd take this over here. If I added x here, I'd have, so what we've got now is 3x plus half x. We've added half an x here to get rid of that. So we add it on the left hand side. So added there. You add it here, it drops out. Add half an x here, it's gone. Add half an x here, and it becomes here. That 2, take it over to the right hand side. So minus 2 here, which cancels it out, plus 2 minus 2, and take 6 minus 2. So we're taking this part over to the right hand side, and we're taking this 2 over to the left hand side. Take this 2 over to the right hand side. So now what we've got is 3.5x equals 4. Okay, 3.5x equals 4. We've got 3x plus a half an x, which is 3.5x. 6 minus 2, 4. 3.5 is 7 over 2x. 3, 2, 6, add 1 is 7. 7 over 2. So 7 over 2 is the same as 3.5. So 7 over 2x equals 4. Multiply by 2. So now we've got 7x equals 8. We multiply the left hand side by 2, we just get 7x on its own. Multiply it by 2, you must multiply the right hand side by 2, so it gives us 8. And when you write it out, you get x equals 8 over 7, or if you like, 1 1/7. Finally, note simple equations have one variable and one equation only. That's what we need to remember. It's a simple equation. There's no complexity here. There's one variable, call it x, or you can call it anything you wish. You can call it a or b or whatever. So we have one variable and one equation, and that's a simple equation. So that's a simple equation. We have one variable, one equation, just one, and we have one variable, x. It appears on both sides in this case, but that's all it is. One variable and one equation is a simple equation. And that's all we're going to deal with. So let's leave it at that and say thank you for watching.